Hi there and welcome to Hegarty Maths. Mr. Arnold here, and this is our fourth video on integration. We're going to be focusing on area under the curve, and it is geared towards A-level maths but is applicable to most other maths modules. Okay, so we're just going to continue the work we've previously been doing on areas under curves, and that involves finding the definite integral. So let's have a look at a few examples here. We're asked to sketch the curve y equals x times x minus 2 times x plus 3 and find the area of the finite region bounded by the curve and the x-axis. Sounds very complicated. Let's start by sketching the function. So I'm going to have my x and y axis like so, and the next thing I want to do is take a look at the function y equals f of x. So we have this function x times x minus 2 times x plus 3, which tells me it's a cubic function, and I can see that the roots of the cubic are at 0 when x is 2 and when x is negative 3. That's the roots of the function. I can also see that it's a positive cubic. The x cubed term is going to be positive, which means it should follow this general shape as x gets bigger and bigger and bigger. So as x goes to infinity, y goes to infinity. And as x goes to negative infinity, as x gets smaller and smaller and smaller, y will also get smaller and smaller and smaller. So what will that look like? The function is going to come up something like this. Going to peak around here, come down below that axis, turn again, and then go off up to infinity. So we've sketched the curve, and our task now is to find the area of the finite region bounded by the curve and the x-axis. In other words, what is this area in here and this area in here? So let's see how we might tackle this problem. If I take a highlighter out, the area between 3 and 0, we're going to calculate this area here by integrating the function, which is x times x minus 2 times x plus 3. I'm going to integrate that with respect to x. And if we integrate that between the bounds negative 3 and 0, that will tell us the area trapped beneath the curve. Now before I do this, what I want to do is expand this out, make life a little bit easier for myself. So I'm going to get, well, this would be x squared minus 2x. So x squared times x is x cubed. X squared times 3 is 3x squared. Negative 2x times x, negative 2x squared. Negative 2x times 3 is negative 6x. Okay, so this is the function that we end up with. I'm just going to tidy it up again. So the integral, let's make a bit more space, the integral between negative 3 and 0 of, I should have brackets around this, and it is respect to x. So that's x cubed plus x squared minus 6x. So we're integrating this function with respect to x. Now just in case you're wondering, I've just expanded this out. I did take a little bit of a shortcut, but you should be able to figure that out. So expand this out and we get this, and now we're going to integrate it. So the integral, will be equal to, I'm going to increase this power of x by 1 and multiply by 1 over that new power. going to increase this power of x by 1 and multiply by that power. And again increasing this power of x by 1 and multiplying by 1 over that power, which is going to give me 3x squared. And what we need to do is to evaluate this integral between negative 3 and 6. So, not negative 3 and 6, I can't read my own writing, that's a 0. Negative 3 and 0. Okay, so substituting in, we're going to get 0, 0 and 0, and then we need to subtract 1/4 times negative 3 to the power 4 plus 1 over 3 times negative 3 cubed minus 3 times negative 3 squared. Now, if you're a little bit unsure, when I put the upper bound in here, just a reminder, when I put the upper bound into this part, we're going to get 0. And then I'm going to take all of this away. So, negative 3 to the power 4, let's see, 3 times 3 is 9, times 3 is 27, times 3 is 81. So we're going to get negative, or positive 81 over 4. 81 over 4. Negative 3 to the power 3 is negative 27. Negative 27 times by a third is negative 9. And then negative 3 squared is positive 9. Positive 9 times negative 3 is negative 27. And I'm going to use the calculator here at this point. Probably should have used it far earlier. So we end up with 81 over 4 minus 9 minus 27 gives me negative 63 over 4, and then we've got to multiply that by a negative number, which is going to give me 63 over 4. 63 over 4. So the area between the curve is 63 over 4. Now, this is a great opportunity to show you how we can use our calculator to check if we've done this correctly. This is a great calculator. Make the most of it. What I'm going to do is actually put this function in from the top. So I'm going to integrate between negative 3 and 0. And what we want to integrate, if I can ever get it there. Here we go. Go back. Okay, so it's x times x minus 2 times x plus 3 closing that off and hit equals, and we get 63 over 4, and look at that, lo and behold, that's exactly what we had, 63 over 4. Wonderful. Okay, so I know that the area under the curve here is 63 over 4. I also need to calculate the area under the curve in this region. So, this other region, which I'll highlight in green, so this region here, the area trapped between the curve and the axis, is going to be found by integrating the function between 0 and 2. So the next part is to integrate. We need to integrate between 0 and 2 the function, and let's use this one, x cubed plus x squared minus 6x, x cubed plus x squared minus 6x, and we're integrating that with respect to x, which is actually going to be the same as what we've done before. We have all of this. We don't need to write that down again. It's going to equal 1/4 x to the 4 plus 1 over 3 x cubed minus 3x squared, and we need to evaluate this between negative 3 and 0. And I'm going to save myself the hassle of doing it all again. I'm going to get my lovely calculator out. There was the original function. Here we had it here. And all I need to do is just change the bounds from 0 to 2. It equals, there we go, it's negative 16 over 3. We get a negative number, and the only reason it's negative is because it's underneath the x-axis. So we have to treat the area as a positive number, so we're going to take the absolute value of that, not use negative 16 over 3. We're going to use positive 16 over 3. And that means that the total area equals 63 over 4 plus the 16 over 3. In fact, I'm going to write that as a negative number and then say, but areas must be positive, just to show the examiner I know what I'm talking about. And again, calculator paper, let the calculator do the hard work here. So we got 16 over 3 plus 63 over 4, which gives us, in fact that was a negative 16 over 3, let's do that again. 16 over 3 plus the 63 over 4 gives us an answer of 253 over 12. 253 over 12. And that's the solution to that question. So we just need to be careful. Areas underneath the x-axis are going to turn out to be negative. We need to treat it as a positive number. Well, let's see another example here. So we've got a curve shown, and part A, we're asked to find the coordinates of the points where the curve crosses the x-axis. So where does this curve cross the x-axis? Well, we should be able to answer that question simply by factorising. So we're going to factorise x squared plus 2x minus 15 equal to 0, which is going to give me x plus 5 and x minus 3 equals 0. The values of x are going to be x equals negative 5 and x equals 3. Now we're asked for coordinates, so let's work out the corresponding y value. Corresponding y value, substituting negative 5 in here. Negative 5 squared is 25. Subtracting 10 and then subtracting 15. Well, it should be fairly obvious that both values should be equal to 0. So we have the coordinates negative 5 and 0 and 3 and 0. Okay, now the next part of the question is to evaluate this integral between 3 and 0. So I'm essentially working out the area between the curve here and here. So part B, we need to evaluate the integral between 0 and 3 of the function, which was x squared plus 2x subtract 15. We're integrating with respect to x. So I will equal, okay, let's increase this power by 1 and multiply by 1 over that power. So just integrating the function, 1/3 x cubed plus power of x is going to become 2, multiply by 1 over 2 and we get 1, and then integrating 15 we get 15x. Now we need to evaluate that between 0 and 3. What we're going to do is you need to do the upper limit subtract the lower limit, so substituting in 1/3 times 3 cubed plus 3 squared minus 15 times 3, close that and then take away Now, when I put 0 in for x, I'm going to get 0. So, 3 cubed is 27. 27 times a third is 9. Plus 9. And then 15 times 3 is 45. So we get 9 and 9 is 18. And that 45 is going to give me negative 27. So the integral gives me an answer of negative 20. But area, in fact, I wasn't asked that part yet. This is part C now. We've evaluated the integral. The last part is state the area of the shaded region enclosed by the curve, the y-axis and the positive x-axis. So in other words, what's this area in here? Well, it must be 27. And once again, just to show you how we might do this with the calculator, you should show your examiner this and use the calculator to check. So I'm going to evaluate the integral between, well, the integral between 3 and 0. There we go. Of x squared plus 2x plus 15. So x squared plus 2x plus minus 15 negative 27, which is what we had here. So a good way to check your answer, and just remembering that areas are positive. Okay, another example here. This time we're asked to find the coordinates of the points where the curve and the line intersect, and then finally to find the area of the shaded region enclosed by the curve and the line. Okay, first thing I'm going to do is focus on finding the coordinates of the points where these two meet. So, how would I solve the coordinates of this and this? So, hopefully a little bit of thought. Simultaneous equation should work. So if y equals this and y equals this, I'm going to let two y values be equal to each other, which implies that x plus 1 must equal x squared minus 3x plus 4. What we're going to do is solve this quadratic. So, keeping x squareds here, I'm going to take an x off both sides. I'm going to take 1 off both sides. And that must be equal to 0. This is looking nice to factorize. So, factoring out negative 3 and x subtract 1 must be equal to 0. Which means that x equals 3 or x equals 1. Alright, lovely. So x equals 3, x equals 1. Now I need coordinates, so let's get those y values. So y should equal. Now, if x equals 3, I'm going to substitute it back in here because we can use either function. When x is 3, y is 4. And when x is 1, y is 2. So the points that we have are the points 1, 2 and the points 3, 4. Lovely. Okay, B is find the area of the shaded region enclosed by the curve and the line. Okay, so I'm looking for this shaded region here. Now, one way I might do it is work out the area trapped between the line and the x-axis. If I work out the area trapped between the line and the x-axis, that will give me all of this region here. And then what I'm going to do is work out the area trapped between the curve and the x-axis, which is going to give me this region here. And then if I subtract the green area away from what was the red area, we should get the shaded area here. So let's just demonstrate again. I'm looking for this, the area trapped between the line and the x-axis, which is going to be this completely red area here. we're going to integrate this function with respect to x. And remember that the x value here is 3 and the x value here is 1. Okay, so part B. We need to integrate between 1 and 3 the function x plus 1. I think it's x plus 1. It is indeed. Function x plus 1. We're integrating with respect to x. So that's going to give me, increasing the power of x by 1, multiplying by that, a half x squared plus x. So we're integrating that, and I need to evaluate it between 1 and 3, which is going to equal a half times 3 squared plus 3. I'm using the wrong brackets here. Let's put them back to where they should be. Right. And I need to subtract from that the lower limit. So substituting this into the integral, a half times 1 squared plus 1. Okay, 3 squared is 9. 9 times a half. 9 over 2. That's 6 over 2. 9 over 2 and 6 over 2 is 15 over 2. 15 over 2. And I need to take away from that. That's going to be 3 over 2. 15 over 2, take away 3 over 2 is 12 over 2, which is 6. So that's the red area. Okay. Now what I want to do is work out the area trapped between the curve and this green area here, which I'm going to shade in. So everything trapped between the curve, not the line, and the x-axis, so this area here, like so. We're going to do that very much the same way we did the last one. So I want the integral between 1 and 3 of the function, where are we? X squared minus 3x plus 4. X squared minus 3x plus 4. We're integrating that with respect to x, and that should give us, so 1 over 3 times x cubed minus 3 over 2 times x squared, and integrating this guy to, why did a 2 there? It's definitely not that. It should be 4x. We need to evaluate that integral between the limits 1 and 3. Okay, so we're going to get 1 over 3 times 3 cubed minus 3 over 2 times 3 squared plus 4 times 3. And I need to take away that lower limit. 1 over 3 times 1 cubed minus 3 over 2 times 1 squared plus 4 times 1. Okie doke. 3 cubed is 27 times a third is 9. I'm using square brackets here. They could be curly brackets as well. Minus 3 over 2 times, let me see, that's going to be 9. 9 times 3 is 27. So 27 over 2 plus 12. And I need to subtract 1 cubed, which is 1/3. 1 cubed is 1, 1 times a third is a third. Minus 3 over 2 plus 4. Okay, certainly got to get the calculator out for this, because otherwise we'll be here all day. Right, so we need 9 minus 27 over 2 plus 12 minus 1 over 3 minus 3 over 2 plus 4, and when we work that out we get 14 over 3. 14 over 3. So the green area is 14 over 3. The red area was 6. So the area trapped between the curve, area between the curve will equal 6 minus 14 over 3, which is going to give me 4 over 3. Now what I want to do is check it. Okay, so I'm going to put this and this into my calculator. Hopefully we've done everything correct. Right, so 3, 1, and we're integrating. There we go. We're integrating x plus 1. So we're going to integrate that. And then what I want to do is I want to take away the green area, so take away the integral between 1 and 3 of x squared minus 3 x plus 4, and we get 4 over 3. Absolutely brilliant. 4 over 3, which is what we calculated ourselves. So the calculator is great for a check there. Okay, similar question here. You might want to try this and find the region enclosed by the line in the curve. So what always helps here is a quick sketch. Quick sketch. Now what's this going to look like? I'm going to factorize it. Let me see. X minus 6 and x plus 1. Now if I expand that out, yeah, lovely, which means where it cuts the axis are going to be 6 and negative 1. 6, negative 1. It's a U-shaped graph, so it's going to come down. Something like that. Just in case you're wondering, that would be a negative 6 as well if you wanted. Not all that important. And here we've got the line y equals x minus 11. So I'm going to use the straight line tool to draw this. I'll change the colour in a moment. Something like that. Y equals x minus 11. It's going to cut the axis at minus 11, and it's got a fairly straightforward gradient. Now, x minus 11. Right, so what we're looking to calculate here is this area in here. Now, the first stage in calculating that area is working out where the curve and the line meets. So I want to know what these values are here. So if I calculate where the curve and the line meet, these points of intersection, it'll allow me to work out the area trapped beneath the curve and the axis. So what we need to do is set the two functions equal to each other. So x squared minus 5x minus 6 must be equal to x minus 11 at some place. So we get x squared, taking x off both sides, minus 6x, adding 11 to both sides is going to give me plus 5, and that must be equal to 0. Now we're going to factorize it, and we get x minus 3 and, beg your pardon, not x minus 3, it's going to be x minus 5 and x minus 1 must be equal to 0, which means we have a value here, x equals 1, and here x will equal 5. Okay, now this is done just like we did the last question. I'm going to work out the area of the curve between the curve and the x-axis. So I'm going to work out this area here, which is everything beneath the curve and the x-axis. And then what I'm going to do is work out everything beneath the curve, sorry, between the line and the x-axis. And then we're going to subtract them. So, area between the curve and x-axis equals, that's going to be the integral between 1 and 5 of the function, which is x squared minus 5x minus 6. We integrate that with respect to x. So when we do that, we get 1 over 3 x cubed. Gotta be careful here. 1 over 3x cubed minus 5 over 2x squared minus 6x. So integrating that, and we need to evaluate between 1 and 5, which will equal, so 1 over 3 times 5 cubed minus 5 over 2 times 5 squared minus 6 times 5. And we need to take away the lower bound, so putting that in now as well. 1 over 3 times 1 cubed minus 5 over 2 times 1 squared minus 6 times 1. Let's get this calculator out before we do any damage. So taking out the calculator, 1 over 3 times 5 cubed minus 5 over 2 times 5 squared minus 6 times 5. Something dreadful has happened here. That's 1 over 3 times 5 cubed minus 5 over 2 times 5 squared minus 6 times 5. Okay. And negative 305 over 6. 305 over 6. And we need to take away from that. The calculator is already out. I need to change all these 5s to 1s. Change that to a 1. Change that to a 1. And change that to a 1. Negative 49 over 6. So I'm taking away negative 49 over 6, which is in fact the same as adding 49 over 6. So 305 multiply that by negative 1, just make life a little bit easier. So that's the adding 49 over 6. I need to take away 305 over 6. Negative 128 over 3. Negative 128 over 3. Okay, so that's the area between the curve and the axis. Now we're going to go for the area between the line and the x-axis. By the way, this is a negative number. That implies that the area is 128 over 3, just in case you were wondering. Alright, so what we're going to need to do now is integrate the line, which is, the line is x minus 11. So we're going to integrate between 1 and 5. double check, it is 1 and 5, 1 and 5 of x minus 11 with respect to x, which will equal a half x squared minus 11x integrating between 1 and 5, or evaluating between 1 and 5, which is going to give me a half times 5 squared minus 11 times 5 minus a half times 1 squared minus 11 times 1. 5 squared 25, 25 over 2 minus 55, 25 over 2 minus 55 minus a half minus 11, which is going to give me minus 10 and a half. Minus 10 and a half. So let's get the calculator to do this again. Save us the hassle. 25 over 2 minus 55 equals that, and I need to take away negative 10.5, which is minus 32. Which implies that the area is 32. So, the area of the region enclosed by the line in the graph, so this black region here, which we shaded in earlier, is going to be found by taking the area of the line away from the area of the curve. The area underneath the line away from the area underneath the curve, so 128 over 3, 128 over 3 minus 32. Get this fantastic calculator out again. 128 over 3 minus 32 equals 32 over 3. 32 over 3. Okay, now, really wise to check what we've been doing here. So, I'm taking the area of the line away from the curve. So, let's do this curve again. That's a 5, 1, and then we've got x squared minus 5, x minus 6. And we're taking away from that the integral between, again, 5 and 1. Of x minus 11. (32 over 3) gives us a negative number here. That's only because it's underneath the axis, but we can see 32 over 3 is exactly what we had. So fantastic. Okay, that's it for this video. Hopefully you found it useful. I'll be back again with another video soon. All the best.